Welcome back. In this video, you'll learn about spot rates and forward rates. Let's get to it. Alright, so spot rates and forward rates are part of a bigger topic in financial mathematics known as the term structure of interest rates. And a simple way to demonstrate what I mean by the term structure of interest rates is to consider a scenario where you are looking to take out a loan. For example, let's say that you're looking to take out a mortgage for a home that you recently bought. Oftentimes, as the borrower, you were given several options on how you plan to repay that loan or repay that mortgage. And so if you consider this table right here, you can see that we have 3 different lengths of a loan that can be taken out. And depending on which of these lengths we choose, the interest rate is going to be different. If you choose to pay off your loan in 10 years, you'll have a 7.25% interest rate. If you choose to pay off the loan in 20 years, you'll have an 8% interest rate. And if you choose to pay off the loan in 30 years, you'll have an 8.75% interest rate. And when you're paying off a loan, you typically want a smaller interest rate because that means that you have to pay less in interest as you are paying off the loan. And so typically this is the term structure that you will see. As the length of the term for the loan increases, the interest rate for that term will also increase. And that makes sense logically, right? Because if the interest rates got smaller instead, as the term length of the loan increases, then there's really no incentive to take out a shorter loan. And the lender of a loan wants to get their money back as soon as possible, right? When you loan someone money, you don't want to have to wait the longest amount of time possible. You want to wait the shortest amount of time possible. You want to get your money back as soon as you can. And so if you offered smaller interest rates for a longer length of a loan, then most people are going to pick that longer loan because they'll get to make smaller payments for that loan because they're paying it over a longer period of time, and they'd be paying less interest if that interest rate was smaller. Alright, so there's really no good reason that somebody wouldn't just pick a longer loan if the interest rates got smaller. So it makes sense for the lender to give out a smaller interest rate for a smaller length of a loan, because then as the borrower, you are more likely to choose a shorter loan because you'll have to pay less interest in the long run, even if the payments of your loan over that shorter amount of time would be bigger than they would be if you picked a longer loan. Alright, so I hope that makes sense. That's what I'm referring to when I mention the term structure of interest rates. Depending on the length of the term for a loan or investment, the interest rates for those terms may be different. And we actually call these interest rates right here in this table spot rates. And all of these spot rates are based on what you choose today. If you chose to pay off a loan in 10 years starting today, you would have an interest rate or a spot rate of 7.25%. But if you chose to pay off the loan in 30 years starting today, you would have an interest rate or spot rate of 8.75%. All right, and all of these spot rates are annual effective interest rates. The effective part, of course, meaning that they are compound interest rates. And so to get a better idea of what spot rates are and how we will use them in calculations, let's take a look at a more basic example. Okay, so here's our more basic scenario. Here we have another table where one column is the length of our investment, typically a loan of some kind, and the other column has our spot rates that correspond to each term length of that investment. And so we have a term length of 1 year, 2 years, and 3 years, and their corresponding spot rates. For a length of 1 year, you'll have a 5% spot rate. For a length of 2 years, you'll have a 6% spot rate. And for a length of 3 years, you'll have a 7% spot rate. Now the notation for spot rates looks like this. This rate right here, this 5% spot rate, that corresponds to a 1-year term would be S sub 1. S sub 1 is equal to 5%. All right, the S stands for spot rate, and we just have a subscript of 1, meaning that this is the spot rate for a 1-year term. And so in the same way, we could say that S sub 2 is equal to 6%, and S sub 3 is equal to 7%. All right, this is a spot rate for a 2-year term, and this is a spot rate for a 3-year term. And there are some other notations that you might see for spot rates. This is the notation I'm going to use here, but sometimes you will also see the notation like this. You'll see S sub 0 of T, and T would just be replaced with that subscript. So the spot rate for a 1-year term would be S sub 0 of 1. The spot rate for a 2-year term would be S sub 0 of 2. And then a spot rate for a 3-year term would be S sub 0 of 3. That's just a different notation you might see, but I'm not going to use that in this video. as I think it's a little bit more confusing than having S sub 1, S sub 2, S sub 3, and so on. Okay, but now if you take a look at this timeline here, we have t equals 0, which is the present day. This is where we are today. Then we have t equals 1, that's 1 year in the future. Then we have t equals 2, 2 years in the future, and t equals 3, which is 3 years in the future. All right, so this spot rate right here, S sub 1, a spot rate for a term length of 1, would accumulate the interest for an investment from today to 1 year in the future. Right, so this 5%, this spot rate right here, would generate interest from t equals 0 to t equals 1. That is where S sub 1 is active. Then for S sub 2 is the spot rate that corresponds to a term length of 2 years, and so S sub 2 would accumulate interest from t equals 0 to t equals 2. So the 6% rate, S sub 2, would generate interest for an investment from t equals 0 to t equals 2. That's S sub 2. And then in the same way, if we look at our third spot rate, our spot rate of 7% for a 3-year term, that would generate interest for a 3-year period from t equals 0 to t equals 3. That is where S sub 3 is active. All right, so depending on the length of an investment made today, you could have these different spot rates. And so if we wanted to calculate the accumulation of an investment today, 1 year later, or 2 years later, or 3 years later, using each of those respective spot rates, here's what that would look like. For S sub 1, the accumulation factor would just be 1 plus S sub 1. Right, to accumulate the interest for an investment from today to 1 year in the future, we just multiply it by 1 plus that spot rate. For S sub 2, the accumulation factor would be 1 plus S sub 2 squared, right? In order to accumulate the interest for an investment today, 2 years into the future, we would need to multiply that investment by the accumulation factor of 1 plus S sub 2 squared to account for both of those years. And then in the same way, for S sub 3, the spot rate for a 3-year term, the accumulation factor would be 1 plus S sub 3 cubed. Multiplying this by an investment that is valued at t equals 0 will bring it forward 3 years to time t equals 3. Okay, so that's what the accumulation factors look like for different spot rates that correspond to different lengths of a term for an investment. And so you can see that for an investment at t equals 0, we could accumulate it from time equals 0 to time equals 1 using S sub 1. We could accumulate an investment from t equals 0 to t equals 2 using S sub 2. And we could accumulate an investment from t equals 0 to t equals 3 using S sub 3, and so on. We could have S sub 4, S sub 5, if those values were also included in a table. And so we're always able to accumulate an investment from time equals 0 to some year in the future. That's what we can use spot rates for. But what if we wanted to accumulate an investment starting at time equals 1 and accumulate it to time equals 2? Or accumulate an investment from time equals 2 to time equals 3, where we're not starting at t equals 0. What rate would we use to accumulate that investment? Well, we're not going to be able to use any of our spot rates, and so here's where we introduce another type of rate that we call forward rates. Forward rates are going to make it possible for us to accumulate an investment from some time that is not time equals 0 to another time in the future. All right, and so here's what forward rates are going to look like. If we want to accumulate the value of an investment at t equals 1 to t equals 2, let's represent that with this arrow. The interest rate that would allow us to accumulate that investment would be a forward rate from time equals 1 to time equals 2. And I'm going to represent that with this notation, f sub 1 comma 2, the forward rate from year 1 to year 2. And then if we wanted to accumulate an investment from time equals 2 to time equals 3, or from year 2 to year 3, we would have another forward rate that we would denote with f sub 2 comma 3. All right, this is the forward rate that accumulates interest from time 2 to time 3. All right, and now before we go any further, a little bit of a side note on notation for forward rates. This is the notation I'm going to use, but there are other notations. In fact, there's a lot of different ways that a forward rate could be represented. I choose to do it this way because I believe it's the most simple way to write it, but here's a couple other ways you might see it. For example, I'm going to rewrite this forward rate right here using the other notations. One way that you might see it is I sub 0 of 1 comma 2. This could also represent a forward rate from time 1 to time 2. Another way you might see it is just I of 1 comma 2, where you don't have that sub 0. This is another way that you might see it. Or you might see capital F sub 1 comma 2, or you might even see small f sub 1 comma 2 like I have right here, but you'll have brackets around those numbers. And then there's actually one more way that you might see it, and this is definitely the most odd one because it doesn't really work like the other notations. Sometimes you'll see this. You'll see a subscript of 1, and then small f, and then another subscript of 1. This means the same thing as what I have right here, but the way it works is a little bit different. The first subscript tells you what time you're starting at, time equals 1, and the second one tells you the length of that forward rate, which is 1 year. All right, so 1 and then f sub 1 tells us that we're starting at year 1 and the forward rate lasts 1 year. So from time 1 to time 2. All right, so I just wanted to take the time to show you those because sometimes different textbooks use different notations, and if you're trying to follow along with this video with your own textbook, you might get a little bit confused with my notation, so I just wanted to make that clear. There's really no universal way to represent a forward rate or even a spot rate, and so I wanted to take the time to make sure that you understand what those different notations might mean if you see them. Okay, so now that we know how to denote a forward rate, how could we figure out what the actual value of a forward rate is, right? We know what these spot rates are equal to. They're given to us in this table, but how do we know what f sub 1 comma 2 or f sub 2 comma 3 is? How can we find the value of those forward rates? Well, what we can do is set up an equation of value for an investment of $1. All right, essentially what that means is we can just write our accumulation factors and we don't have to worry about multiplying them by any value because they just be multiplied by an investment of $1. And what we can do is accumulate that investment of $1 from time equals 0 to some year in the future that will allow us to solve for our forward rates. And so let me show you what I mean. Let's start with this forward rate right here, f sub 1 comma 2. Notice that this forward rate takes us from time 1 to time 2. And so if we were to accumulate an investment from time equals 0 to time equals 2, we could write an equation of value as follows. We'll start by accumulating our investment of $1 by multiplying it by the accumulation factor for s sub 2 squared. Right, this right here will take our investment of $1 from time equals 0 to time equals 2. And this right here, that's going to be equal to accumulating our investment from time equals 0 to time equals 1 using s sub 1 and then accumulating it another year forward by using this forward rate to accumulate from time equals 1 to time equals 2. So that'll look like this. We'll have 1 plus s sub 1 to the power of 1, right? This accumulation factor is only accumulating interest for 1 year, and then we'll multiply that by the accumulation factor for the forward rate. We'll have 1 plus f sub 1 comma 2. And now we have an equation that will allow us to solve for the value of our forward rate, f sub 1 comma 2. We know what s sub 1 is equal to, it's 5%, and we know that s sub 2 is equal to 6%. And so by setting up this equation, we can now find our forward rate. All right, and so let's solve for f sub 1 comma 2. Since s sub 2 is 6%, we're going to have 1.06 squared, and that will be equal to 1 plus s sub 1, which is 5%. So we'll have 1.05, and then we're multiplying by 1 plus f sub 1 comma 2. All right, now if we divide both sides by 1.05, we'll have 1.06 squared divided by 1.05, and that will be equal to 1 plus f sub 1 comma 2. All right, now 1.06 squared divided by 1.05, if you plug that into your calculator and then subtract 1 from both sides of the equation, we can solve for f sub 1 comma 2, and we'll find that the forward rate is equal to 0.0701, and there are some more decimals there, but I'm going to cut it off. And so the forward rate from year 1 to year 2 is about a 7% rate, 7.01%. And so that's how we can solve for a forward rate. What this forward rate is telling us here is that if we have an investment at t equals 0, the accumulation of that investment using s sub 2 to take us to time equals 2 will be the same accumulation as if we used s sub 1 for the first year and this forward rate for the second year. We will have the same amount of accumulation for an investment for a 2-year period with s sub 2 as we would with these two different rates for the first year and the second year. Okay, so that's the idea of a forward rate. Now we could also find this forward rate right here, f sub 2 comma 3, by using this same process. So let's do that. In order to find f sub 2 comma 3, we'll need to accumulate our investment of $1 from t equals 0 to t equals 3 using s sub 3, and then equate that to accumulating our investment from t equals 0 to t equals 2 using s sub 2, and then accumulating it for an additional year using f sub 2 comma 3. Right, so here's what that's going to look like. We'll first start by accumulating our investment using s sub 3 for 3 years, and we're going to say that that is equal to accumulating our investment from time equals 0 to time equals 2 using s sub 2, and then multiplying it by the accumulation factor for f sub 2 comma 3. All right, so we'll have 1 plus s sub 2 squared times 1 plus f sub 2 comma 3. Now we already know what s sub 3 and s sub 2 are equal to. S sub 3 is 7% and S sub 2 is 6%, so we can plug those values in and solve for this forward rate of F sub 2 comma 3. And so let's do that. We'll have 1.07 cubed, right? S sub 3 is 7%, so 1 plus 7% will be 1.07, and that will be equal to 1 plus S sub 2, which is 6%, and that quantity is squared, so we will have 1.06 squared, and then we're still multiplying by 1 plus f sub 2 comma 3. Now if we divide both sides by 1.06 squared, that will help us isolate and solve for this forward rate. We'll have 1.07 cubed divided by 1.06 squared, and that will be equal to 1 plus f sub 2 comma 3. Now just like with our other forward rate, if you evaluate this fraction and then subtract this 1 from both sides of the equation, you would find that f sub 2 comma 3 is equal to 0.0903 and some more decimals. In other words, our forward rate is a rate of 9.03%. All right, and so what we learned from this calculation is that having an interest rate of 7% for 3 years is the same as having an interest rate of 6% for 2 years and then 9.03% for the last year. All right, so now you've seen the process of setting up an equation of value in order to solve for a forward rate, but now what we want to do is actually find a generalized formula that will allow us to solve for a forward rate given some spot rates. In particular, we're going to find the general formula for finding a forward rate that only takes place for 1 year. And to find that, all we have to do is analyze this last step when we solved for f sub 2 comma 3. We can notice a pretty nice pattern in this calculation. Notice that the forward rate from year 2 to year 3 includes both the spot rates for a 2-year term and a 3-year term, right? We have 1 plus s sub 3 right here cubed divided by 1 plus s sub 2 squared right here. So whenever you want to find a forward rate that has a 1-year gap, the spot rates that you will use to calculate that forward rate are going to depend on what those 2 years are that you want to know the forward rate between. And so here's how we can generalize this. What we'll do is we'll rewrite the forward rate generally like this. We'll have f sub n minus 1 comma n. All right, whatever our value of n is, we're just looking at a 1-year gap. So we're looking at a forward rate from n minus 1 to n. All right, so in this case, 3 would be n, and so n minus 1 would be 3 minus 1, which would be 2. So that ensures that we're looking at a 1-year gap between the 2 years for our forward rate. This is going to be equal to this expression right here, but more generally, it will look like this. We're going to have 1 plus s sub n to the power of n divided by 1 plus s sub n minus 1 to the power of n minus 1, right? In the numerator, we had 1 plus s sub 3, that was our value of n, 3 is our value of n, so we had 1 plus s sub 3, or s sub n to the power of n, the power of 3, divided by 1 plus s sub 2, which is our value of n minus 1, and then we have the power of 2, which is also n minus 1. All right, so in other words, we have the accumulation factor for the spot rate that corresponds to a term length of n divided by the accumulation factor for the spot rate that has a term length of n minus 1. And then there's one more thing we can't forget, which is to subtract this 1 from this calculation to get that forward rate. So we'll have minus 1. That right there is the general formula for calculating a forward rate that takes place between 2 years that are only 1 year apart. And typically you will see that called an n minus 1 year forward rate. Essentially what that means is that this forward rate right here that I've been calling f sub 2 comma 3, we would call this a 2-year forward rate. All right, n minus 1 is 2, so this is a 2-year forward rate. It takes us from year 2 to year 3. All right, and these types of forward rates are the most common type of forward rate that you will encounter. But there is another type. We could also have a forward rate that doesn't span a 1-year period, but it spans more than 1 year. So for example, what if we wanted to know the forward rate from time equals 1 to time equals 3? We would represent that with this notation of f sub 1 comma 3. We no longer have a gap of 1 year between our 2 years here. We now have a gap of 2 years. And this could be bigger too. We could have a forward rate from year 1 to year 4, but I don't have a year 4 drawn here, but we could have that, and many other types of forward rates that span a period of more than just 1 year. And so the question is, how could we calculate a forward rate like this? Well, the process is very similar. We will also set up an equation of value. So let's do that here. Notice that this forward rate is accumulating an investment from year 1 to year 3. So the investment is valued at year 3. So here's what we can do. We can say that the value of the investment by using the 3-year spot rate that will take us to year 3 will be the same as using a spot rate s sub 1 and then the forward rate f sub 1 comma 3. That will take you from year 1 to year 3. And let me show you what that looks like. We'll have 1 plus s sub 3 cubed is equal to 1 plus s sub 1 to the power of 1 times 1 plus f sub 1 comma 3 squared. All right, so what we're saying here is that if we accumulate our investment from time equals 0 to time equals 3 using s sub 3, our 3-year spot rate, that will be the same as accumulating our investment from time 0 to time 1 using s sub 1, and then accumulating the investment from time 1 to time 3 using f sub 1 comma 3. And of course, that accumulation factor needs to be squared because it's taking place over a 2-year period. All right, and so this is our setup, and then just like with our other equations, all we have to do now is plug in the values of the spot rates that we know, and then solve for f sub 1 comma 3. And I'll do that here real quick. We'll have 1 plus s sub 3, which is 7%, so we'll have 1.07 cubed, and that will be equal to 1 plus s sub 1, which is 5%, so we have 1.05, and that's still multiplied by 1 plus f sub 1 comma 3 squared. And then to solve for this forward rate, we need to divide both sides by 1.05, so we'll have 1.07 cubed divided by 1.05, and that will be equal to 1 plus f sub 1 comma 3 squared. But if we take the square root of both sides, then we'll get closer to solving for this forward rate. So I'm going to do that. I'm just going to erase this. So we'll have the square root of this expression. And so taking the square root of 1.07 cubed divided by 1.05, and then subtracting 1 from that value, will solve for f sub 1 comma 3. And so that will give us that f sub 1 comma 3, this forward rate is equal to 0.0801 and some more decimals. All right, so that's how you would solve for a forward rate that takes place between 2 years that are more than 1 year apart. Okay, and we could also find a general formula to solve for these types of forward rates, although we're not going to use this last step in this case because this is a little bit more complicated due to this square root. It's not always going to be a square root. What type of root you will have, whether it's a cubed root, a square root, or like a fourth root, or any other root, is dependent on the amount of years between the 2 years that the forward rate is active for. All right, so that makes things a little bit more tricky. So instead of generalizing this step of the process, we're just going to generalize the first step. All right, so here's how that's going to work. Here's how we'll write the general formula for a forward rate that takes place between 2 years that are more than 1 year apart. We're going to represent it like this. We're going to have 1 plus f sub k comma n, and that will be raised to the power of n minus k. All right, so in this case, 1 was k, 3 was n, so n minus k is 3 minus 1, which gives us 2. So that quantity is squared. And then using those values of k and n, we can set up the rest of this equation. We'll be multiplying by another accumulation factor of 1 plus s sub k to the power of k, right? 1 is k, so we'll have 1 plus s sub k to the power of k. In this case, this accumulation factor was raised to the power of 1, and this will be equal to 1 plus s sub n to the power of n, right? In this case, 3 is n, so we have 1 plus s sub 3 to the power of 3, so we'll have 1 plus s sub n to the power of n. All right, so this is a general formula, or the general setup for calculating a forward rate that takes place between 2 years that are more than 1 year apart. All right, and just a helpful visual for how this works, if we have a timeline like this is year 0, this is year k, and this is year n, and this would continue on from there. The spot rate s sub k generates interest for this period. The spot rate s sub n generates interest for this period, and then the forward rate that we're calculating generates interest from k to n. So we have f sub k comma n. All right, so this spot rate s sub k generates interest from time 0 to time k. This spot rate s sub n generates interest from time 0 to time n, right? Spot rates always start at time 0, and then this forward rate is the forward rate that we're trying to solve for, which generates interest between year k and year n. It doesn't start at 0, it starts at some other year and ends at some other year in the future that is more than 1 year later after k. All right, and so those are the two general formulas that you need to know for finding different types of forward rates. And one more thing that I want to note, you won't use this too often, but sometimes this might be necessary. Occasionally you may encounter a forward rate like this. You might see a forward rate of f sub 0 comma 1, a forward rate that starts at time 0 and ends at time 1. That's not really a forward rate. In fact, that's just equal to s sub 1, the spot rate for a 1-year term. So if you ever see f sub 0 comma 1, just know that that's the same as s sub 1, or if you're given s sub 1, it might be advantageous to know that that is equal to f sub 0 comma 1 as well. It depends on the problem. You might not ever use this at all, but it can come in handy in some types of problems. And so to summarize, here's our formula for calculating an n-1 year forward rate. F sub n-1 comma n is equal to 1 plus s sub n to the power of n divided by 1 plus s sub n-1 to the power of n-1, and then you subtract 1. All right, and then our other formula for a forward rate f sub k comma n is this formula right here, where you have 1 plus s sub n to the power of n is equal to 1 plus s sub k to the power of k times 1 plus f sub k comma n to the power of n minus k. All right, so you set up this equation, and then you can solve for f sub k minus n to find your forward rate. Okay, now before we end this lesson, there's one more thing I want to talk about, which is another term that you might encounter when working with spot rates and forward rates. All right, now sometimes when working with spot rates and forward rates, you may encounter the term yield curve or yield curves. The yield curve is just a graph that corresponds to that table of spot rates that we were using. If we were to extend those values to be continuous, right, in those tables we just had spot rates for a 1-year term, a 2-year term, and a 3-year term. A yield curve would also include spot rates for a term of 1.5 years or 1.75 years or 2.1 years. Basically any term that isn't discrete or a countable value like 1, 2, 3, 4, and so on. And generally a yield curve will look like this right here. It's an increasing and concave down curve. The yield rate or the spot rates will generally increase, but increase slowly as the amount of years for the term increases. All right, so this is the general shape of most yield curves. You're not really expected to know how to draw these curves or how to create them. You just really should know what it is, and this is basically all it is. But just a side note, if all the spot rates are equal, if it never changes, what you'll have is a flat yield curve. In other words, the curve is a horizontal line. It'll look something like this because the yield rate or those spot rates never change. In fact, for this whole course up to this point, we have been assuming a flat yield curve. For example, with annuity notation and bonds, we were always assuming that no matter the length of the term, the yield rate, interest rate, whatever, would always be the same. All right, and there are actually some concepts in financial mathematics that will require a flat yield curve rather than a yield curve that looks like this. And so you might encounter that in the future, but for now, all you have to know is that this is the general shape of a yield curve, and if all the spot rates are equal, then you'll have a flat yield curve. Okay, and so with that, that is the end of this lesson. If you want to see some example problems of using spot rates and forward rates, feel free to check out my examples video. If you have any questions, feel free to leave those in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.